Remember, displacement and distance are two different things. And as you can see on the red line, displacement, distance is the distance traveled, the path traveled, whereas in the white line, displacement is the shortest path from A to B that the thing has traveled, in this case, the car. Hello, hello, hello. Okay, so like I was saying before, right? We have S, we have U, we have V, we have A, and we have T, right? So we know S. I don't know why it's not a D, but it is what it is, right? S is displacement. Displacement. Oops. Displacement. U is initial velocity. I'm just going to write velocity. But remember, it's initial velocity. This U and V are always velocity. This represents initial velocity, where V also represents final velocity, right? Remember to differentiate the two, right? So I'm just gonna put an I in the front, right? Velocity, right? And then if I could just gonna copy that, paste that here, right? Put that there, boom, right? And then accelerate. A stands for acceleration, obviously. Acceleration. So on, so on. T, obviously, for time, right? You guys will remember this over time. Don't worry about it. You guys will remember it, right? So now that you guys know that, what each of them stand for, right? Let me just erase this. I just want to reinforce something to you guys, right? So remember, guys, S and D and D are not the same. Right now, you're going to be saying, "What? What are you talking about?" Obviously, they're not the same. These letters aren't the same, but you guys don't know what I'm referring to. Some of you guys know. So S, okay, okay. Let's differentiate two things, right? We have S for speed, right? S for speed, and D for distance, right? Oops, this my pen's bugging. For distance, right? This you've learned before, like speed is equal to distance over time, right? You guys learned this before, right? So I want you guys to not confuse S and D with displacement and distance, right? Because these are used differently. Like these are now SUVAT equations where um, acceleration has to be uniform, right? So in SUVAT equations, the acceleration A has to be uniform. Uniform. And remember, A stands for acceleration. Acceleration. Right? And what do I mean by uniform? Uniform means it's constant. Whenever they say uniform, it means constant, right? So you can have a situation where A is increasing, but as long as it's increasing at a steady rate or at a constant rate, steady and constant, same thing, right? Then you can use SUVAT equations, right? That's very important for you guys to remember, right? And back to the point I was saying here, S and D are not the same. By that, what I mean by that, sorry, is S stands for displacement in SUVAT equations. Displacement. Uh, I'm just gonna rush it because I don't have space. Where D stands for distance. Distance. Right. Remember, in this equation from primary school, whatever you guys want to call it, S would stand for speed, but here S stands for displacement, right? S and D are not the same, right? So displacement and distance are not the same. Remember this, S and D are not the same. Displacement and distance are not the same. Trust me, you'll remember it one day. Okay? So what I mean by that, the difference between distance and displacement is, hold on a second, get that out of here. So let's say we have a car, right? I'm just gonna draw a box, right? I'm just gonna draw a box. C. This car is named, right? It's a car. C for car, right? And this car travels, oops, this car travels in a straight path, right? This car travels in a straight path, right? And it reaches at a distance of 25 meters, right? And then we have another car, right? Where it starts at the same point and will end at the same point, right? But to reach the same point, right, he goes a different route. Instead of going straight forward, he goes up, then down. Oops, I don't know why it's doing that. Okay, okay, up, okay. Technical difficulties here. Okay, okay, guys. Okay. I'm just gonna use the pen. He goes up, then down, then up, and then reaches the same point, which is point B, and the starting point is point A, right? The starting point is point A, right? So when he goes up, he traveled a distance of 10 meters. When he went down, 20 meters, back up, 20 meters, and down 10 meters, right? Meters, meters, and meters, right? So the total distance traveled by this car is 10 plus 20 plus 20 plus 10. So 20 plus 20, 40, 10 plus 10, 20. So 40 plus 20, 60, right? So the distance traveled by this car is 60, right? But the displacement is 25. Why, you guys ask? Because displacement is the shortest path from point A, from the starting point to the final point. Okay? Just for me to, just so I can reinforce that, so you guys believe me, displacement, here it is in Google, right? Displacement is defined as the change in position of an object. It is a vector quantity and has direction and magnitude. right? I'll talk about this in a bit. Don't worry about it right now. I'll talk about the direction and magnitude. It is represented by an arrow from the starting position to the final position, just like I said, guys. Just like I said. Listen to me, guys. So, okay, something's wrong. Okay, so um, now you guys want to know what a vector quantity is. So basically, before, distance is a scalar quantity, right? Distance. It's a scalar quantity. Distance, basically, a scalar quantity is basically when you only have magnitude. By magnitude, I mean a number, right? So, for example, um, I traveled, uh, what was it? 60 meters, right? 60 meters, right? That is distance is a scalar quantity because it only has a number, while displacement is a vector because it has a magnitude. It has a magnitude and a direction, right? And a direction. I'm running out of space here, right? So displacement will have direction, which you guys have in vectors. So like, uh, forget about this example. It can be 2, 1, whatever it is. So 2 in the x direction and 1 in the y direction. So the the vector quantity would be this, right? It would be this, right? And yeah, remember there's the difference between scalar and vector quantity, guys. And that's it, guys. Okay, let's have an example where we have a plane dropping off a box, right? So as you can see, there's a downwards force pulling on the box, which is known as gravity, right? Which is the acceleration, right? The acceleration is 9.81, right? And we don't know the mass, right? So we can't calculate the force, but we know the acceleration on Earth, right? Which is 9.81. And so we use that to calculate the distance. So we don't know the distance. We know the initial velocity, which is 0, because from the start, it didn't move. It was at rest. We know the final velocity. We know the acceleration, 9.81, and we know the time taken. So we just plug those in the equation and then use algebra and boom, that's it. Mission completed.